All right. For those of you who don't know me, I'm Chris West from Interop.io, where I work as FDC3's lead maintainer, and I'm joined today by Rob from FINOS. We're going to talk to you a bit about FDC3 2.2 and our work to bring FDC3 to web browsers. But first, one of the first things we did in the 2.2 scope was adopt Brian's work, who's sitting in the second row here, to build a .NET binding for FDC3. So it's a set of interfaces and utility help classes that will help you implement your own desktop agent in .NET or leverage FDC3 from .NET applications. So it's up there available on both GitHub and NuGet, along with a PR that's in review to update it to FDC3 2.1 and all the new intents and contexts we added there. And as we've officially adopted it, when FDC3 2.2 is released, that will be available by default on the FDC3 website. For the time being, if you want to go and take a look, use the version menu to go and select main and unreleased, and you can see the binding translated from TypeScript into .NET, along with all of the examples and everything else that Brian's worked very hard to translate for us. We've also, in 2.2, created some new context documentation to allow us to use the JSON schema files that define context as a single source of truth. So we generate the documentation files now along with the TypeScript sources, and that makes it a lot easier for us to have that single source of truth and make it a lot easier to contribute. It's part of our work to try and move the governance of context types outside of the versioning for the API standards versions, which naturally move an awful lot slower. We've also done a fair few things with FDC3's governance. We updated its charter or scope to better describe what we all understand as the mandate for FDC3, and done various things to improve branch protection, set up code owners, etc. Again, with lots of Brian's help. We've refined a small number of contexts and intents this time. There was a lot more of that in 2.1. But you can now share actions better, or you will be able to share actions better through the FDC3 action type, which is used to attach things to messages, a file attachment type for messages, as well as making it easier to create profiles for organizations and people in CRMs. We've also done a fair bit of work to the project's infrastructure. So we're partway through creating a modern monorepo to support the many facets of the FDC3 software that we now need to maintain, as well as looking to move to ES6 for all of our releases and numerous other small improvements. But the bit that's probably most interesting in 2.2 is bringing FDC3 to web browsers, which is no small project. So to tell you a little bit more about that, I think it's probably worth starting by asking the question, hasn't FDC3 always been about web apps? It was from the beginning, but it was designed for Electron-based containers. These give you greater control over web security and other processes in the system than you get in a web browser, and it's often used to bridge between native monoliths and modern web apps. It does this by injecting an FDC3 API implementation at window.fdc3 in the window scope, something we're now starting to call a desktop agent preload interface. And web browser-based desktop agents have existed for a number of years. My own firm publishes IO Connect browser and Glue42 core before it, which have been around for years, but they have a problem in that they can't inject that FDC3 API implementation in the window scope. Instead, apps have to import a vendor library instead, which will do it for them. And unfortunately, that means they only support a particular desktop agent implementation. There's no ability for them to write once and run anywhere with just one set of libraries. And that's fine for something you might call interop, working with your own applications in a platform you publish, but it's not great for interop between third-party applications and your own. You have to make a bilateral agreement on which vendor you're going to work with. Now, some of the challenges we faced in trying to solve this include and start with FDC3 not specifying what we call a wire protocol, basically a set of rules for how a service talks to its clients. Instead, FDC3 is a set of interfaces that describe the shape and behavior of an API, which is implemented by different firms. And each implementation is different. They have a different internal wire protocol. So there are no open or vendor agnostic solutions to write once, run anywhere under that. There are also various different ways you could implement a desktop agent in a browser. You might use local messaging between windows supported by HTML standard APIs, or you might do messaging up to a server with a WebSocket. You might have applications all in the same window using iframes, or you might have them each in their own web window or tab, or more likely some combination of the two. And of course, anything we do with FDC3, anything we do in finance, in software, has to be secure. And unfortunately, in web browsers, windows are quite easy to navigate, and apps can change identity into different applications, which is something the FDC3 standard doesn't take much of a view on at the moment. But FDC3 for the web has to. And ease of use has always been key to FDC3. It's one of the things that's driven the high uptake of the FDC3 API over other interoperability standards that have been around longer, but just haven't achieved the same sort of use. And we always want to have backwards compatibility so that applications don't have to be maintained to continue doing things that they always do, or always did. So if we solve this and we bring FDC3 to web browsers, what's the impact? Well, we protect the ability to write once, run anywhere, and really help develop the FDC3 ecosystem, preventing it from fragmenting into different vendor-specific factions. We reduce the slow, expensive, and repetitive integration projects further. That's always been part of FDC3's mission and mandate. Make it easier for public websites to participate in FDC3. They don't have to be developed to work in a desktop agent. We can just add code into Yahoo Finance or other similar applications to make them work inside a desktop agent and share context with other things. There's no need for additional deployments or infrastructure in order to do that. You just simply put a bit of extra code in the web page. And that will help bring browser-based desktop agents into the mainstream. There's no installation required to these, which means they've got a lower barrier to adoption for products delivered inside the web browser. It should make buy and sell side integrations easier to do because of that. And it helps FDC3 move beyond just the trader desktop to more job roles, and perhaps even beyond finance as well. We could also use other parts of the FDC3 standard and combine them. For example, the desktop agent bridging protocol that we added in FDC3 2.1 would allow browser-based desktop agents to cooperate with container-based desktop agents running on the same machine. That makes it a lot easier for a whole suite of applications deployed in their own browser-based desktop agent to be incorporated into somebody's workflow. It eliminates the reintegration work you have to do at the moment, lifting the pieces from that suite and putting them into your own desktop. The adopter then has less configuration to manage, and the vendor needs to provide less support and can add and remove components whenever they want to. They don't have to get all of their clients to update their configuration to pop these things in. So how does it work under the hood? There are a few components to the solution. One is a new getAgent function in the FINOS FDC3 NPM module. It's a simple unified function intended to help you acquire a desktop agent that you use whether you're working in a container or in a browser. We had to define a web connection protocol that governs how that actually works. How do you locate and communicate with the different types of desktop agent? We created a desktop agent communication protocol, which is a set of standardized messages for all the things that you do in the FDC3 API, and some support for injectable user interfaces for things like channel selectors and intent resolvers that are typically provided by the desktop agent to applications that they're supporting. But before anyone who's heard me talk about FDC3 for the web before runs for the exit to avoid a rather dry description of a set of protocols, we're going to stick to just the tip of the iceberg here. There's a lot of detail involved in doing this. And if you're interested in that detail, you can go and check out our talk from OSFF in London, which includes most of the gory detail. But to give you just that very light summary, the Web Connection Protocol provides standardization for the procedures for locating a desktop agent of all types, message transport for the desktop agent and the applications to actually communicate based on the HTML standards, channel messaging API, some storage for instance data based on, again, the HTML standard session storage API, which is involved in our validation of app and instance identities, which often connect back to an FDC3 app directory record. And it's a flexible approach. It supports multiple formats of web-based desktop agent. The desktop agents can communicate directly or pass details of some sort of adapter to load, for example, to help them talk to a web a web service for a sort of SaaS-based desktop agent, and even to fail over to an alternative approach. If they don't find a desktop agent, they could start their own one or load an adapter to talk to a proprietary DA. The desktop agent communication protocol is basically defined in JSON or JSON schema, and that allows us to generate TypeScript types for each message for people to use in their desktop agents, which we do via QuickType in the same way that we do with context or the bridging APIs. And there's a number of different message types basically governing requests from apps to the desktop agent, the responses from the desktop agent back, number of events that happen, for example, context being broadcast, and a bunch of messages that help you communicate with those injected user interfaces. It's used to implement something we call a desktop agent proxy, which is the alternative to the desktop agent preload that I talked about before. Basically means an app with just the FDC3 library in it can talk to any conformant desktop agent. And that lays a few foundations for the future. It means we could start to write multi-language adapters for FDC3. Because we got that wire protocol, we could use it over, for example, a WebSocket and implement clients for lots of these different languages that would all then talk to the same endpoint on a desktop agent. And then we have the getAgent function that uses these two things to do what it does. It's the utility function to retrieve a desktop agent, supporting DAs of all sorts of types, so apps running in container-based desktop agents, child apps that were started by a desktop agent running in the web, and apps that were started independently. Somebody just typed in a URL, they can still associate with the desktop agent in some way. And it can be used to rapidly retrofit existing apps to make them ready for the web. Basically, it can set window.fdc3 for their implementations, and it basically replaces the old ready pattern. You take this code out, replace it with a very simple call to getAgent, and that will attach you to the desktop agent, give you the reference for it. There's a number of optional arguments to change how it behaves, and you can set up that failover function to do something else if it didn't find one. This is intended to become the new recommended approach for getting access to the FDC3 API, whoever you work with. And then what about the user interfaces? Typically, they're provided by the desktop agent to applications. Apps can implement their own, but they're often needed to select a user channel, say a color channel, to link to other components, or an intent resolver. If you raise an intent, there are multiple options. The user needs to pick one to send it to. Desktop agents in the browser may be able to provide their own, but that often depends on the window topology. Are they loading apps into iframes, allowing them to display something over the top? That in turn depends on clickjacking protection or iframe embedding protections that may prevent that. And getAgent allows you to go the other way and actually inject something instead as an iframe, but with the capability for both the apps and the desktop agent to indicate whether they need that. So the getAgent code will take instruction from both sides and act accordingly. It also allows the desktop agents to continue supplying their own implementations without a code import. As part of the protocol, they simply give a URL for where you will find their versions that then have to conform to the desktop agent communication protocol to work. So with that, I'm going to hand you over to Rob, who is going to demonstrate some of his work that's been pretty essential to the whole process to basically try some of these out, proof of concept them, and make sure that they actually work for us. Which he's had to do an awful lot of work for on over the last 18 months.
How's of you? Hi. Hi, everyone. We all having fun? Good. Good. Yes, so as Chris points out, I mean, there's a lot of stuff here. There's a lot of stuff going on, and browsers have been around a long time. So we knew when we started this that we'd actually have to build an implementation as we went along. There's no point in just coming up with all this stuff and not having tested it out, because you don't know what a browser sandbox is going to prevent you from doing. So for anyone who came to my London talk, I'm just going to pre-say what we discussed there, so back in January, I sort of whipped together a quick demo of how FDC3 for the web might work, and it kind of looked like this. And back then we had just like simple broadcaster and receiver applications, so I'm going to start these up. And if I press the broadcast button in this app, then this app starts receiving messages. So really simple stuff. And this originally used the desktop agent bridging protocol. But obviously, with all the work Chris has been doing, we've upgraded this now so that it actually uses those protocols he's mentioned today. And we've also got to the things like the channel selector and intent resolver that Chris was talking about. So right in the bottom corner here, if I press this button, this is the channel, and I can move this guy onto the blue channel. And it stops receiving messages now because this one is on the red channel. So they're different channels and they don't listen to each other. But if I move this one to the blue channel as well, this guy starts receiving messages again. So this is a part of FDC3. And another key part of FDC3 is obviously raising intents and passing workflows between applications. So we put in the FDC3 workbench into this demo. And if I go to intents and I try and raise an intent, let's raise an Apple context. Then it pops up a intent resolver. And we had Juliana from Interop.io kind of design some standard UIs here, but as the demo goes on, you'll see how you can override these with desktop FDC3 for the web. So if I pick an app here, you see it sort of raises the intent there. And back in the workbench, I can see the result of that intent too. So after we'd started messing around with all these concepts, we realized, actually, we just need to do conformance again. So if I go to here, this is one I prepared earlier. So this is like the conformance results for our demo implementation. So in a way, this is kind of the third new conformance result of the day after the Morgan Stanley and BlackRock ones we heard earlier. We'll probably announce this properly at some future juncture. But so the demo implementation, our reference implementation, passed all the conformance tests. So we knew we had something that conformed to FDC3. And so what I've been working on more recently is something called FDC3 Sale, which a lot of you will be familiar with. If I just go to this page here, this is FDC3 Sale in the FINOS repository. And this was an Electron version of an FDC3 desktop agent built by Nick Colbert and Seb Ben Mubarak. And they presented this at OSFF back in 2022. And I think that might be the reason why Dove made his FDC3 con joke back then. So I thought what we need to do, where is it? Let's go to this tab. So the conformance for FDC3 Sale is lagging here, right? We've got 1.2 conformance, but we never got around to doing the 2.0. So I thought, here's an opportunity. We can take the Sale, we can rewrite it using FDC3 for the web, and we can bring it on and get it conformant with 2.0 and run it all in the browser, and then maybe FINOS can host it somewhere as well, so you can just run it at a URL. And so that's what I'm going to try and demonstrate next. So if I go back to here, let's close some of these guys down. And the point of this is, obviously, FINOS has all these training courses we run with FDC3, so it's good for us to have this pedagogic tool. But also, this kind of demonstrates the flexibility of FDC3 for the web. So this is Sale 2.0. I've got my different user channels here, so we're on channel 1. And I can start the workbench again here. So if I click there, it'll open in the tab. And let's just try raising an intent again. So if I go to, let's raise that Apple intent again. So it pulls up an intent resolver. Now this is a different intent resolver to the one we saw before, so that demonstrates that we're able to replace the UI. And I'm gonna do a view chart here. So I'll click OK. And you can see the chart showing up there. And just like before in the demo, if I broadcast, say Apple, no, we're on Apple already, aren't we? So let's broadcast Microsoft, then it will change, and the context in this user channel has just changed. And again, calling back to the stuff that Chris was talking about, different tabs, iframes, all the windows and things. If I click on FDC3 Workbench and I launch it in a tab now, then you can see here we've got a channel selector, again, a sale channel selector rather than the one built in. I can put that on channel 1, and then let's just broadcast a further intent. So I'll broadcast meta this time. And if I go back into here, you should see, yeah, there we go, meta platform. So the context has changed back in the original window again. So this is quite a nice tool for learning about FDC3, and I've got a talk in about half an hour. If anyone wants to come along and get cracking and do a bit of development with me on FDC3, then come along to my workshop and you can have a go. But I'm going to pass back to Chris now for some closing remarks. Let me find your presentation again, Chris.
That would help.
No? Up?
Yeah.
There we go.
Thank you.
Thank you. I'll just wait here.
And if you'd like to see another web-based desktop agent in action, you can check out my colleague Juliana's presentation tomorrow in the music box on how to add FDC3 for your apps, which you'll do in the IO Connect browser web sandbox. So just a few sort of closing remarks. We're raising this as an experimental feature of FDC3 2.2, and that's a designation we use to handle some of the diametrically opposed opinions from different stakeholders in FDC3. So many of the vendors will comment back that they don't want to see something go into the standard and used in production, before it's been used in production. They want to see it demonstrated out there in the wild. But a lot of the adopters are not going to use it in production until it is standardized, and these two things just don't meet in the middle. So we created the experimental designation. We've added it in here. It exempts the feature set from FDC3's normal versioning and deprecation policies, which also means if we discover problems in production or in attempting to use it that way, we can make those changes rapidly. But we expect to be able to remove that pretty quickly. We're already aware of at least 5 implementations either out there or in the works. Several open source, obviously the reference implementations Rob's just shown you, as well as FDC3 Standard. Our colleagues from Morgan Stanley have both an open source and a proprietary or closed source implementation in the works. And of course, over at interoperability, we've got IO Connect browser working with Get Agent as well. So next steps for getting this done. The first we managed, and one of the most important, we managed to complete at Thursday's Standards Working Group meeting, where we got consensus that we should adopt FDC3 for the web into the current draft of 2.2. The next step is to close out the editor and maintainer reviews, which might even close tonight if we're lucky. That allows us to then merge it into the site and put it up there. We'll then be working to productionize the proof of concept implementations that have been done that help us provide the software support in the NPM module that we publish. The reference implementations need the same treatment, so they need to pass reviews before they merge into the FDC3 repository. And then finally, the Standards Working Group will vote to adopt a tag of the repository as 2.2. which will allow us to release it to NPM. And then we've got more work to do on updating the FDC3 conformance framework to use it, although I think Rob's got a chunk of that done already by the look of things. And then we've got to update the FDC3 training courses and FINOS certified FDC3 practitioner exam. So with that, I'd like to thank a bunch of people who've been involved in getting this done. Derek Navavi, who presented with us in London at S&P Global Market Intelligence, who's done a lot of work on the proposal and some very early exploratory work. The teams, multiple teams at Morgan Stanley, Giles, David, Brian, Paul, Peter, and too many others for me to put on this particular row. So thank you very much for exploring and implementing this while we were going. Alexandru Dumitru at Citi, who's been working on the FDC3 monorepo. Some other members of the interoperability team, Terry Thorson, who helped start the first draft of the documentation, and Juliana, who worked on the reference implementations for the UIs. Hugh, over at FactSet, I see over there, is FDC3's editor, who has to read and review everything that we write and put into the standard. And many other participants in the FDC3 for web browsers discussion group. There's too many to mention here. People like Pavlo, RBC, Johan from OpenFin have been there every time. And last but not least, obviously, Rob and the FINOS board for voting in FDC3 as a strategic initiative last year, which has given us Rob's support and enabled us to do a lot of this work in the first place. So with that, Just a few notes on what's next for FDC3. We're looking ahead to 2.3 already. There's a lot of different issues open at the moment, things like resetting context on channels so that you can clear filters, etc., supporting analytics, pushing data into open telemetry and linking different API calls across different apps together into the same customer interaction. Lots of things we need to do in the context types, like representing currency pairs better or better order, trade, and position types. And lots of intents and context to support more roles. So if you have business needs or business stakeholders who need to talk about the things you need to do in interop, send them along to the use cases discussion group. It's intended to be friendly for a non-developer audience and help us build the mandate for what we need to do in the standard next. But one of my personal favorites is the work of the FDC3 Identity and Threat Modeling discussion group, which Yannick down here runs, who are working on enabling deeper transactional integrations, for example, buy-side and sell-side integrations that need stronger identity and security solutions than FDC3 has at the moment. That might include adopting more vendor-owned app directories with secure app identities in them, identity validation procedures on connection or navigation, something that FDC3 for the web is actually slightly better at than traditional FDC3, cryptographically signed messages, or encrypted communication that's facilitated by the desktop agent but actually protected from it and from the other apps that it supports. So if you're interested in that, come and see their talk from the Symphony, Morgan Stanley and Wellington teams on secure inter-app communication with FDC3, which is, again, tomorrow in the music box. So lastly, FDC3 is a community standard. What do you need to do with it in future? I've given a bunch of examples here of issues that are currently open, things like saving state in layouts or window configuration in the app directory, actionable notification APIs, but these don't necessarily matter as much as what you need to do with it now. So come along and talk to us about your use cases or any shortcomings, any questions you've got about how to do something in the standard. If you've identified a gap, we need to work on filling it, for which we need your input. So if you're interested in getting involved, remember that FDC3 is a community-run project hosted by FINOS. It provides both standards and software, and as an open source project, FDC3 is only as strong as the will of its contributors to do that maintenance. So we need more contributors. We need standards and software maintainers to come and actually support it, keep it current, implement some of the changes, do organizing activities, and we need more editors and reviewers to keep us, correct, honest, and up to date. So I'll leave you with the thought that FDC3 is a standard for applications to work together, and that is something we can only achieve if we work together as a community. Somebody can't just do it on their own. So we need you to come and support the standard. If you're making use of it, if you're getting value out of FDC3, come and help us keep it working, improve it, etc. So thank you, everyone, and thank you again to everyone who's been involved in making this happen.